Okay, my screen is visible to all of you. Is it? So good afternoon all. This is Vipul and we were discussing about hypothesis testing in our previous session and now we will continue from that only. So let me quickly take you guys towards that slide. Sampling estimation, how to predict the confidence interval and sampling distribution. This is what we had discussed about. We are good with the hypothesis. What is null hypothesis? What is alternative hypothesis? We know that both that are the mutually exclusive statement. And then we had taken introduction of the two-sided alternative hypothesis and single-sided. That means one-sided alternative hypothesis. One of them is non-directional hypothesis. As we discussed yesterday, that two-sided alternative hypothesis is non-directional. We are not worried whether we are dealing with the less than or greater than. We will be just dealing with the equal or not equal. Okay, in the two-sided alternative hypothesis. If we are dealing with the one-sided alternative hypothesis, then we will be surely interested in one of the fixed direction, either in the right-hand side or in the left-hand side. So, in other words, we will be surely dealing with the less than or greater than. Is it? Uh, uh, in other words, simply, we can say that if alternative hypothesis includes less than or greater than, then it will be one-sided alternative hypothesis. And if alternative hypothesis includes not equal to, then surely it will be two-sided alternative hypothesis. But that alternative hypothesis we are supposed to construct based on the data, based on the situation. वो कैसे करेंगे? That we will learn. And after that, I had introduced that there will be two different types of error. Uh, because none of the hypothesis tests will be accurate. None of the hypothesis tests will be accurate because we are dealing with a kind of probability over there. We are dealing with the normal data and we are dealing with the kind of probability over there. So none of the hypothesis will give us the 100% accurate results. So there will be errors and in hypothesis testing दो ही टाइप की एरर हो सकती है that error will be either type 1 or type 2. Here it is, type 1 error, type 2 error. When type 1 error will be generated, will be occurred if a hypothesis, if a null hypothesis is true and we are going to reject that. Null hypothesis सही होने के बावजूद अगर हम reject कर रहे हैं उसको, then there is an error, and such kind of error will be known as a type 1 error. And the other case, although our null hypothesis is wrong, false, and we are going to accept that, गलत है फिर भी accept कर रहे, जो error है उसको type 2 error बोलते हैं, सही है और reject कर रहे तो जो एरर है उसको टाइप 1 एरर बोलते हैं. ठीक है. एंड आफ्टर दैट how to accept and reject the null hypothesis इसकी बात हो रही थी. So to accept and reject null hypothesis will be depending on the test hypothesis. The test hypothesis will differ test by test. और उसकी जनरल फॉर्मेट जो थी मैंने कल बताया था, that is t minus e of t divided by standard error of t. But that test hypothesis will be known as Z. Usually we will be labeling that as a Z. And the value of Z, we are going to compare that value of Z with the critical value. The critical value will be labeled as Z alpha. If Z is gonna less than Z alpha, then a null hypothesis H0 will be accepted. And if Z is gonna greater than the Z alpha, then we will conclude that a null hypothesis is rejected. So this will be the process how we are going to accept or reject the null hypothesis, or in the words we can say that fail to reject the null hypothesis किस तरीके से करेंगे. So for that acceptance or rejection, we will be in need of two different values, Z and Z alpha, where Z alpha is our critical value and Z will be a test statistic. हर एक टेस्ट के लिए टेस्ट स्टैटिस्टिक कुछ अलग होगा. वो कैसे, उसका एक फॉर्मूला बनेगा. I will provide you one of the formula for the Z statistic, and you will be comparing both that. Now, we are clear on with the Z. For to determine Z, I will provide you the formula for respective test. But what about Z alpha? Z alpha is a critical value. Critical value. Now, uh, that critical value is depending on the alpha. Now, what is alpha? Alpha is level of significance. Level of significance. That level of significance might be vary. That कुछ भी रख सकते हैं आप. You may set your level of significance. You may set up to 1% or 2% or 3% or 3.5%, or you may, if you wish, then you may set it up to 40%. Is it? But the uh, usually we will be dealing with these three figures only: 1% or 5% or 10%. सो ज्यादातर इन तीनों के साथ ही बात होगी. या तो 1% सिग्निफिकेंस लेवल से साथ बात करेंगे, या तो 5%, या तो 10%. नाउ लेट मी क्लियर इट वंस अगेन व्हाट वी मीन बाय 5% लेवल ऑफ सिग्निफिकेंस. 5% level of significance means we are allowing 5% of error out of 100. If that is out of 100 trial, if we are having five times error, then we are good with that. We are allowing 5% error over there, but more than 5% will not be tolerable. Okay, so this is the meaning of level of significance. Give me just 1 minute. Yes, ma'am. Sorry, I was having a call. Sorry. Okay. So we were discussing about the level of significance. So this is the meaning of level of significance. Level of significance. 1% money. We will be good with the 1% error. More than 1% will not be tolerable. Okay. 10%. Similarly, for the 10%, if there is a 10% error, then we are good with that. But more than 10% will not be acceptable. Okay. So let me. Yes, this was the table lastly we were discussing about that this table includes the different critical value. As I said that to accept or reject any of the null hypothesis, any of the hypothesis in any of the equation, we will be dealing with two different values, z and z alpha. Among that, z is our test statistic. This is our test statistic. For that, I will provide you the formula respective to the that particular test. And this z alpha is a critical value. Now you may identify a z alpha. You may identify your z alpha, that z alpha is a critical value that based on alpha. कि alpha क्या ले रहे हैं आप? As I just said, alpha आप कुछ भी set कर सकते हैं. You may set the value of alpha as 1, 2, 3, 4, 5, 50%, any of that. But this three, 1%, 5%, and 10% are the usual level of the error जिसी के साथ हम बात करेंगे. So what I'm doing, I'm giving you the critical values over here in this table. You are having two different options. Either you may remember this, या तो आप इसको याद रख सकते हैं. And the second option, you may identify your Z alpha. But if you wish to identify your Z alpha, then you will be in need of normal table. As I said yesterday, before delivering this particular session, I will take care for the D2D student, but in the morning slot, that was not possible. So we are having one of the session for the D2D guys today afternoon, that is 2:30 to 4:30. So I will be delivering that particular how to deal with the normal table and all that value of Z and any of the नॉर्मल वेरिएट वो मैं आज ही आपको समझा दूंगा सारे D2D बच्चों को. But that section will be after this regular academic, that will be on uh, 2:30 to 4:30. Is it? If any of the other regular student want to attend that session, I'll be dealing with the regression as well as normal distribution. आज की 2:30 से 4:30 वाले सेशन में नॉर्मल डिस्ट्रीब्यूशन की बात होगी और रिग्रेशन एनालिसिस की बात होगी. If any of you wish to attend that, then drop a message after this session. मुझे एक मैसेज ड्रॉप कर देना. I will add you guys on that. अगर किसी ने वो मिस कर दिया था तो there is a second chance with the D2D student. Okay, so that critical value you may calculate from the normal table even, पर अगर वो नॉर्मल टेबल से आइडेंटिफाई करनी है तो कैसे करना है. कल हमने कुछ तो छोटी सी उसकी बात की थी, दैन टाइम खत्म हो गया था तो फिर वो बात पूरी नहीं हो चुकी थी. आज हम वो खत्म करेंगे. चलिए पहले ये देखते हैं हाउ वी कैन डिसाइड दैट एनी ऑफ द क्रिटिकल वैल्यू. किसी भी क्रिटिकल वैल्यू की बात करनी है तो कैसे ये कोई भी वैल्यू, जैसे कि ये यहाँ पे देखिए व्हाट इज दिस. दिस इज z alpha equals to 1.28. अब उसके लिए लेवल ऑफ सिग्निफिकेंस क्या है 10%. और कौन सी टेस्ट की बात हो रही है, दैट इज राइट टेल टेस्ट. Right tail test, right tail test, left tail test, that means one-sided test. So this will be for one-sided test, and this is the two-sided test. If we are dealing with the two-tail test or two-sided test, then the critical values for the 1% level of significance, that will be 2.58. Critical value for the 5% level of significance, that will be 1.96, and 1.645 for the 10%. This three figures, these three critical values are for two-sided, or I can say two-tail test. Okay, and we need to compare as a statistic if we are dealing with the two-tail test with this particular critical values. We will be comparing as that statistic with these three values. We will be not dealing with all three together. We will be dealing with one of them, but that purely based on whether we are dealing with the whether hypothesis, alternative hypothesis is two-tailed or one-tailed. Two-sided alternative hypothesis या single-sided है, उसके ऊपर based होगा. देखिए, and let me erase this. So just give me 1 minute. Yes, and observe this figures. These are same. There's just difference. छोटा सा ही difference है वो क्या है, positive negative, is it? If we're dealing on the right hand side, then that value will be positive. If we're dealing with the left hand side, then that value will be negative. But we'll be not worried about that. We will be not worried about that because usually we will be dealing with the absolute value about that. We'll be dealing with the absolute value. Okay, so ये positive negative अगर ये आप याद नहीं भी रख रहे तो भी कोई इशू नहीं है. We're good with that because we are going to deal with the absolute value of the Z statistic as well as the critical value, is it? So both these rows include the critical values for the single-sided test, whether it is right tail or left tail. Okay. Now let me once again explain one of them. Let me explain both this. How to determine the value, how to identify that critical value. ऐसे तो you are not supposed to identify that, but one must be clear with the concept. One must be good with that particular data. The core knowledge of the subject must be there in your mind, and that will help you in the future. So let me explain both these figures, how I can identify the critical value if I'm dealing with the one-tail test and the level of significance is 5%, then why that Z alpha is 1.645. And if we're dealing with the two-tail test and level of significance at the 5%, then why that critical value is 196. For that, I will be in need of normal table. So quickly, let me pick my normal table. उसकी जरूरत पड़ेगी. Just give me 1 minute. वो मैं एक और टैब में ओपन रख रहा हूँ ताकि जब भी चाहूँ तब वो आपको दिखा सकूं. ठीक है. Okay, good. Okay, so when we are, let's quickly identify. Let me add one more slide over there that will help us. Eight, this card, and let me start it once again. Stop presenting. Window and Let me share my entire screen, that will help us. Good. Just small time. So now my entire screen is will be visible to you. Yes, it is. So I can switch. Yes, so it'll be good for me. Screen, white screen. Yes, and let me pick my pen. Good. So चलिए दोनों की बात कर लेते हैं. What we mean by single tail test, उसमें कैसे critical value decide होती है, and two tail test. Suppose, as we all know that we will be dealing with the normal distribution each and every time, and we are dealing with the hypothesis testing. So यहाँ पे बात कर लेते हैं one tail test. One tail test. How to decide the critical value over there, and let's discuss two tail test over here. And let's fix x's also. So this is the mean, and first let's deal with the one tail test. If we are dealing with the one tail test, if we are checking whether my alternative hypothesis is less than or greater than some of the value, then surely we will be dealing with this single tail test. So assume we are dealing with the right tail test over here, and as we know that the entire area of this normal curve is always one. So the area on the right to the mean means this, all this, that will be surely 0.5. The area will be 0.5 of this region, is it? So what is this? What is this? This is the, as we all know that the area of the entire normal curve is always one. So यहाँ पे area इस तरफ का area 1.5 होगा, इस तरफ का area 0.5 होगा. And suppose we are setting a level of significance. That means alpha की value हम set करें 5%. That means we are allowing 5% error over there. We are allowing 5% error over there. So what I am supposed to do, 5%, मानी कि that is 0.05, and I will be cancelling that particular portion of 0.05 from the right end, from the right tail. So let me pick the other color from here. Where is the ink color? Yes, here it is. What I will be doing, I will ignore this particular region. ये suppose कि 5% है, and as we are dealing with the single tail test, so एक ही तरफ से 5% में निकाल दूंगा कि भाई we are not interested in that. This is area of rejection. मतलब क्या है इसका? 5% से अगर ज्यादा है, इससे बढ़ गया ना, then we are not gonna accept that, is it? They're good if it is less than 5%. So all this entire this region, let me pick the color again, different color again. Yes, this entire region I am representing from the green color, that is the area of acceptation. अगर हमारे Z statistic की वैल्यू यहाँ पे कहीं है, तो माने की मतलब क्या है कि 5% से एरर कम है. That means we can accept that this is area of acceptance. So this green portion is area of acceptance. This blue area is area of rejection. And take care, we are dealing with the one tail test. Now, what we are looking for, we are interested in this particular partition. किस point से वो partition हो रहा है? That point is critical value Z alpha. We need to decide now. We need to decide one of the point on the one of the end that कहाँ से कहाँ तक अगर जाएगी Z statistic की value, then हम ऐसे accept करेंगे, and from which point we are gonna reject that, is it? So we need to identify the Z alpha. From where we can identify the Z alpha? For that Z alpha we will be in need of normal table. वो हमको identify करनी है normal table से, because we are dealing with the normal distribution, normal data, is it? So what is alpha? Alpha is my level of significance. Alpha की value है 5%. 5% माने कि 0.05. I need to subtract 0.05 from zero point 0.5 because the entire area is zero point 0.5, and I'm ignoring 0.05. So what I will be doing, 0.5 minus 0.05, इसको सब्ट्रैक्ट करूंगा, क्या आएगा चलिए बताइए मुझे. 0.495. Is it? Yes or no? Hello. Am I audible to all of you? Am I audible to all of you? How many of you are attending this session properly? How many of you are attending this session properly? Let me know quickly. Will it be 0.95, 0.495? Yes or no? Hello? Or it will be
Yes,
0.50,
yes, sir.
450. ये क्या होगा? 495 or तो 0.450.
Sir, 0.45.
0.45, yes. Yes. So what I will be looking for, I will be looking for this particular value on the normal table. 0.45 की वैल्यू कहाँ पे, नॉर्मल टेबल पे. 0.45 की वैल्यू जहाँ पे आ रही है, where that particular 0.45 is there in the normal table, that will be the value of Z alpha. And वो सारी वैल्यू मैंने देके रखी है आपको, that particular table, that these are the critical values. And instead of dealing with the 5%, if I'm interested in 1% error, if I'm setting my level of significance at 1%, then this 1% means 0.01. So कल हमने जो किया था, that is I'm gonna subtract 1% from 0.5, that will be 0.01, and that will give us 0.49. Is it? So yesterday we were looking for this particular value where the 0.49 is there in the normal table. Now, if you are interested to identify, the critical value for the 5% level of significance, then we will be looking for where the 0.45 gonna stand on the normal table. And if instead of dealing with the 1%, 5%, if we are looking for the 10%, that means we will be subtracting 0. That 10% error. 10% means 0.1. I'll be finding 0.5 minus 0.1. That means 0.4. That means 0.40, where the 0.40 stands in the normal table. Now, what is this? These three are the figures. मैं यहाँ पे लिख दूं फिर से एक बार 0.45. This is for the 1%. Sorry, this is for the 5%. 1% के लिए that figure was 0.49, and for the 10% that figure is 0.40. Now, what we are supposed to identify, this is my Z score. Actually, I'm supposed to identify for where this 3 stands in the normal table, and that will be known as Z alpha. That will be known as Z alpha. That means my critical value. So let's try to identify this 3 on the normal table. 0.45, 0.49, and 0.40 कहाँ पे stand कर रहे हैं normal table में. That 3 will lead us towards the Z alpha for the respective level of significance. So are we good with that? If you are good with this, then I will switch my screen to the normal table and we'll be identifying where the 0.45 stands. Are we good? Are we good? Drop a message on the chat box right now. समझ में आ रहा है नहीं आ रहा है, कुछ भी डाउट है प्लीज पूछिए. Bhati saying yes. Srinarayan saying yes. All those who are attending the session are supposed to reply. समझ में आ रहा है तो भी ठीक है, नहीं आ रहा है तो भी ठीक है. If you are not getting that, please let me know. I will explain it once again. Okay, so hopefully all of you are getting. So what we are doing, first of all, we are looking for 0.45. देखिए हमने we had identified 3 different values. That was 0.45, 0.49, and 0.40. So first of all, let's try to get the value 0.49. कहाँ पे set हो रही है? This is the normal table right now on your screen, and observe this is 0.49. 0.4901. If I'm gonna round off that particular value up to 2 decimal, then it will stand for 0.49, and that 0.49 is for 2.3, and this column is for 0.03. That's it. So 0.49 के लिए जो Z alpha, that means critical value है ना, that is 2.33, and if you're gonna compare that with my table, then observe here. We were dealing with the one-sided test, is it? And the level of significance was where it is. Yes, it is. Firstly, we were looking for 0.49. That means 1% level of significance. And this is what the value of Z alpha. 2.33 is it, and you can easily identify this from this particular table. If you are looking for 0.49 तो वो आएगा 2.3 और ये column जो है ना, this particular column is for 0.03. So 2.3 plus 0.03 will gives you 2.33. So this is what I had mentioned over here. Z alpha critical value for the right tail test. अगर यही बात अगर आप left tail test के लिए कर रहे हैं, if you are dealing with the left tail test, then that value will be minus. So it will not gonna differ, क्योंकि अभी तक हम बात कर रहे थे राइट हैंड साइड में, वही हम लेफ्ट हैंड साइड में बात कर सकते हैं. And we know that our normal table is purely symmetric with mean. ऐसे मीन के साथ सिमेट्रिक है, सो कोई दिक्कत नहीं है. वी आर नॉट वरीड अबाउट दिस पर्टिकुलर. इसके बारे में कोई कंफ्यूजन नहीं है, कोई इसके साथ हम बात ही नहीं करेंगे, क्योंकि बिकॉज यूजुअली वी विल बी डीलिंग विद द एब्सोल्यूट वैल्यू. ओके, सो राइट टेल टेस्ट में अगर 1% लेवल ऑफ सिग्निफिकेंस है तो 2.33 क्यों है ये अब आपको पता है. चलिए अब देखते हैं 5% के लिए वो फिगर क्या था, 0.45 इज इट. For the 5% that z score was 0.45. So चलिए देखते हैं 0.45 कहाँ पे आता है नॉर्मल टेबल में. If you try to identify 0.45, then yes, observe this. 0.45 will stand between this. This value is 0.4495. This value is 0.4505. Now, surely 0.45000 will be in between this, exactly in between this. इन दोनों के बिल्कुल बीच में होगा. चलिए तो हम इन दोनों का एवरेज ले लेते हैं. This value, this particular value is for 1.6 and this will be for 0.01234. And sure, yes, this is 0.04. ये 0.04 के लिए. So हमारी एक वैल्यू आ गई, that is 1.64. And what is this? Well, this will be surely 1.65. So 1.64, 1.65 का अगर आप एवरेज निकाले, 1.64, 1.65 का अगर आप एवरेज निकाले तो क्या होगा? 1.64, 1.65 अगर आप एवरेज निकाले क्या होगा? चलिए कौन बताएगा मुझे जल्दी से. 1.64, 1.65 का.
1.645.
Yes, and observe the value. Observe the value over here. Yes, Mohammed, observe this. Is it 1.645? So this is the reason why the Z's critical value, Z alpha, for 5% level of significance is 1.645. Now, hopefully you will be good with this. ये आपको तुरंत ही समझ में आ जाएगा. 10% level of significance उसके लिए Z score था, that was 0.4. So 0.4 कहाँ पे आ रहा है? देखिए यहाँ पे 0.4 कहाँ पे आ रहा है, जल्दी से देख लेते हैं. 0.4, 0.4, 0.4. Observe here. Observe it. This and this one. If you're gonna take average of both this, then surely you will have this value 1.645. Sorry, 1.28. 1.28. देख सकते हैं आप यहाँ पे. Where it is? Yes, here it is. This is for उसके लिए जो column है, that is 1.2. Is it? And the respective value column की अगर आप value ले ले, then it will be 1.28 approximately. Is it? So this is the reason. This is the way one can identify your critical value. ये मैंने क्यों सिखाया आपको? Why I'm explaining this instead of giving you this table? ये table देने से पहले मैं आप table देने के अलावा मैं क्यों explain कर रहा हूँ? Because this is not. It's totally okay. In the example, we are just gonna deal with this 3 level of significance: 1%, 5%, 10%. अभी के लिए सारे जो क्वेश्चन है उसमें इन तीनों की बात होगी. But it is not like that कि always that level of significance will be among these 3. हो सकता है that level of significance is 20%. If you are interested in one of the example and in that example you want to set your level of significance up to 20%, then you must have the value, you must have that critical value for that level of significance. And now you guys are clear how to identify your critical value from the normal table. Am I good? Am I clear? Am I clear? Am I clear with that? All of you are good with this? Quickly let me know. And then we'll be discussing this, how it's different from the two-tailed test. Good. Almost all of you are good with that. Good. So Instead of dealing with the single tail test, if we are dealing with the two tail test, अगर हम टू टेल टेस्ट की बात कर रहे हैं, मान लीजिए अब तक जो बात हो रही थी that was single tail test, we are dealing with the right tail or left tail, but if we are dealing with the two tail test, then the difference will be, then the logic will be something like that. In the two tail test, we will be having the area of rejection in both the side. We will be having the area of rejection on both the side. Earlier, पिछली बार क्या हो रहा था? We were interested in single tail test, तो यहाँ पे एक ही side था, that was area of rejection. That was the only area of rejection. Is it now? If I deal with the two tail test, then we will have the area of rejection on both the side. What is this? This is area of rejection. Area of rejection. Similarly, this is also the area of rejection. Why we are having area of rejection on both the side? Because now we are dealing with two tail test. And rest of the part, let me pick the different color, and all the rest of the part, all this part will be known as my area of acceptance. This is what? Area of acceptance. Acceptance. Is it? Now, here, once again, we'll be interested in identifying that value from where the area of rejection and acceptance is differ. So this will be known as Z alpha. This is also known as Z alpha, and one can easily identify this Z alpha will be positive and this Z alpha will be negative. Is it? Because this is on the left hand side, this is on the right hand side of the mean. Normal data is normal data. That means यहाँ पे zero ही होगा उसका mean, वो पता है हमको. So this will be positive, this will be negative. Now, in this particular two-tail test, this is known as two-tail test. Sorry. If we are gonna set 5% level of significance, अगर मैं alpha को set कर रहा हूँ 5% पे, that means I am setting 0.05. Alpha की value जो है 0.05. Now, earlier, पिछली बार क्या हो रहा था? What we were doing in the one-tail test, I was subtracting 0.05 from the 0.5. मैं एक ही तरफ से 0.5 में से ही वो 0.05 सब्ट्रैक्ट कर रहा था. I was subtracting 0.05 from the 0.5 because I was interested in one of the half only. Now what we need to do, I need to subtract 5%. I need to reject that 5% from both the sides, and that both side will be equally. So I will be dividing that 5% into two half, 2.5% and 2.5%. That 2.5% will be here. This will be my 2.5%, and this will be also my 2.5%. So what I need to do, I need to subtract 2.5% from 0.5 now. 2.5%. That 2.5%, give me 1 minute, 2.5, that we will be subtracting 0.025 from 0.50, and that will be 0.475. So this will be my z-score for 5% level of significant in two-tail test, and I will be interested where that 0.475 stands in the normal table. Am I clear? Suppose instead of dealing with the 5% level of significance, if I'm looking for 10% level of significance, तो मैं क्या करूंगा? दोनों तरफ से 5% निकालूंगा. That means I need to subtract 0.05 from one of the side. That means 0.5. Is it? So this is the difference in one-sided tail and two-sided tail. And now to verify that my 5% level of significance for the two-side test, I need to just know where 0.475 stands in the normal table. सो बस अभी जैसे मैं स्क्रीन अल्टर करूंगा ये चली जाएगी. सो बी विथ मी. 0.475 कहाँ पे स्टैंड हो रहा है? दैट विल गिव मी द z alpha. दैट मींस क्रिटिकल वैल्यू फॉर टू साइड टेस्ट फॉर 5% लेवल ऑफ सिग्निफिकेंस. सो चलिए मैं वो दिखाता हूँ आपको. 0.475 कहाँ पे स्टैंड हो रहा है? चलिए. 0.475, 0.475. Yes, observe this is the exact value 0.475 in the normal table. And where it is? It is 1.9, 1.9, and 1.96. Is it? This is the column for 0.06. This is the column for 1.9. So this 0.4750 stands at 1.96 और वही वैल्यू होगी मेरे नॉर्मल टेबल में. देखिए, with the level of significance 5% on the two-sided test, the z score, sorry, the critical value is 1.96. The similar manner, with the similar fashion, you can identify that 2.58 as well as 1.645. You can easily identify that 1.645 and 2.58. Are we good with this? So hopefully you guys are clear with कैसे टू टेल टेस्ट और सिंगल टेल टेस्ट में हम वो z अल्फा दैट मींस क्रिटिकल वैल्यू निकाल सकते हैं. अब आपके लिए बहुत आसान है. इफ यू कैन रिमेंबर दिस टेबल देन इट विल बी गुड. यू आर नॉट सपोज टू डील विद दैट नॉर्मल टेबल. आपको नॉर्मल टेबल में नहीं जाना पड़ेगा. आपको पता है ये तीन लेवल के लिए क्रिटिकल वैल्यू क्या है. अगर वो आपने याद रखा है देन वी आर गुड विद दैट. इज इट? बट इफ यू विश टू आइडेंटिफाई यू कैन. After that, okay. Before going for the next one, please let me know. Are we good with this? Are we good with this table? This is very, very important. This is very, very important. So drop your message, drop your comment on the chat box right now. Let me know you guys are clear with this or not. If and only if all of you are clear, then uh, we will move forward. Drop your message. Kindly acknowledge on the chat box right now. सिर्फ 6 ही लोगों ने वो एक्नॉलेज किया अभी तक. 6-7. ऋषभ, सॉरी, भारती इज गुड. मोहम्मद, ऋषभ, विभूषा, वैशाली, मानव, प्रांजुल, बहुदीप. प्रांजुल, आर वी गुड विद दिस? कल जो आपका कुछ क्वेश्चन था, क्या ये सॉल्व हो गया वो क्वेश्चन? प्रांजुल, आई एम आस्किंग टू यू. होपफुली वो क्लियर हो गया होगा तेरा डाउट कल था जो जो तू लास्ट में पूछा था मुझे. यस सर.
ये सर समझ में आ गया.
Good. So what is one more time I had mentioned the confidence interval over there, confidence limit. Once we are having that level of significance with us, level of that critical value with us, based on that particular critical value, we can set our level of confidence interval, or in other words, we can say that confidence limits, the limits within which a hypothesis should lie, which with specified probability are called confidence limits. Generally, the confidence limits are set up with 5%, 1% level of significance. If the sample value lies between the confidence limits, then the hypothesis will be accepted. If it does not, then hypothesis will be rejected. जैसे कि मैंने बोला, let me take you to the next slide. Yes, observe this. Give me 1 minute. Suppose this is my normal table, and both these are my critical values. And if that z score lies over here, जिसको मैंने highlight किया, if that z score lies over here, then surely I'm going to reject my null hypothesis. This is what the acceptance area is, and both these will be my rejection areas. Okay. This is for two tail test. Suppose I'm dealing with the single tail test. तो acceptance area और rejection area एक ही side मिलेगा. देखिए, this will be my area of rejection, and this will be my area of acceptance. Okay. This is for the right tail test. Similarly, I can represent for the left tail test. Is it good? So hopefully this thing is clear to all of you. Now let's move further. Which test to apply? Now the biggest thing. अब तक क्या बात हुई? We are good with the some of the fundamental की भाई कोई हाइपोथेसिस कैसे सेट करनी, how to set null hypothesis, how to set alternate hypothesis, then after how to accept and how to reject, when we will be accepting, when we will be rejecting that null hypothesis, what is the level of significance, वो भी हमने देखा, वो भी हमने समझा, what are the critical values, how we can calculate the critical value from the normal table, वो भी हमने देखा. But now, as I said that we will be having different tests based on the sample, with which statistic we are dealing with. We are dealing with the mean, or we are dealing with the data related to proportion, whether we are dealing with the coefficient of correlation. Based on all that, we'll be having some different tests. We'll be dealing with some of the different tests. Now, इस टेबल में अभी जो मैंने आपको दिया हुआ है, this is the total idea beyond for the hypothesis testing. But we are not supposed to learn all this. We are supposed to cover the sorry, this particular wait, what's wrong with this, what's wrong with this, yes, just give me 1 minute. Anyway, yes. From this table, we will be just dealing with in our syllabus that Z test and chi-square test is included. But this is not the only test कि जो apply हो सकता है. इसके अलावा भी कुछ है. वो क्या है? That is T test and F test, वो भी है. But that is not included in our syllabus. So we will be dealing with the Z test and chi-square test. Okay. But one must be good with the fundamental. मैं जितने भी बच्चों को पढ़ा रहा हूँ, they must be clear with the things कि भाई और कौन सा रास्ता है, किस तरीके से हो सकता है, और भी क्या कोई तरीका है या नहीं. Do we have any alternate way? Do we have any alternate method? Yes, we have lots of. Okay. So what I'm doing, I'm dividing the test in by two different categories: parametric and non-parametric. How parametric and non-parametric? Suppose if we are dealing with one of the parametric value of the sample. Parametric value means if we are dealing with the sample mean, if we are dealing with the sample proportion, if we are dealing with that standard deviation of sample, if we are dealing with the coefficient of correlation with the sample, then all that tests will be known as a parametric test, because we are dealing with one of the parameter. Because we are dealing with one of the parameter related to that sample. But instead of dealing with any of the parameter, कोई भी parameter नहीं है हमारे पास, फिर भी अगर if we want to check, if we want to go for the hypothesis testing, then we will be having a chi-square test, and that chi-square test is known as non-parametric test. उसमें ना तो कोई sample mean होगा, ना तो कोई proportion होगा, ना तो कोई coefficient of correlation होगा. We'll be just dealing with the some of the random experiment. Okay, so based on that, we are dividing a test in two categories: parametric and non-parametric test. We will be starting with the parametric test. Now, in the parametric test, if a population is large, we know that if a population is large मानी कि it is greater than 30, or if the standard deviation is known, if the standard deviation is known, if the population is large or standard deviation is known, then we will be applying the Z test. If population is small, अगर population छोटी from which we are having one of the criteria from where we are saying larger and small, that is 30. If it is less than 30, then we'll be consider that as a small, or standard deviation is unknown. या तो population छोटी होनी चाहिए या तो फिर standard deviation नहीं पता होना चाहिए. In that case, we may go for the T test. If we are having sample variance, if standard deviation is, if the population is small and we are having sample variance, अगर उसका variance है हमारे पास, then we may go for the F test. And we are not gonna deal with both, that is T test and F test. उसकी बात नहीं करेंगे अभी तो. And to check comparability of observed and expected frequency. Observed and expected frequency की comparability अगर check करनी है, then we are having one of the tests, that is chi-square test. So we'll be dealing with Z test and chi-square test. Observe, this is the toughest part from the chapter. You need to decide your test, whether you are dealing with the Z test or chi-square test. पर आपके लिए थोड़ा आसान होगा क्योंकि If we are dealing with the parameters, then it will be Z test. If we are dealing with, if we are just dealing with the frequencies, observed and expected frequencies, then you will be having a single test, that is a chi-square test. Okay, so for this particular syllabus, it will be easy for you guys, but it is not that much easy. Take care for that. To decide among Z test, T test, and F test, we need to remember these things. Population large है या छोटी है, sample standard deviation दिया हुआ है नहीं दिया हुआ है, we are having variance or not, all that criteria will help you to decide your test. Now, uh, let me divide. No. As I said, that large sample, small sample. I'm giving you one of the kind of flow chart which will surely help you to decide your test. As I said, that this is the toughest part. This is the toughest part from the chapter, to decide which of the test is gonna apply. Which of the test is gonna apply. Now, as I said, that we are interested in Z test. Ab Z test may be काफी variety है. We are having so many variety in the Z test. We are having so many different Z statistic in the Z test. Because what is Z test? In the Z test, we will be having one of the parameter with us. Now, might be that parameter is mean, might be that parameter is proportion, might be that parameter is difference of proportion. Okay, so based on that, this is the bifurcation of the test. Based on this particular table, you may decide your test. Hypothesis test, we may divide in two parts: large sample test as well as small sample test. Now, usually we will be dealing with the large sample test, the small sample test, that is T test and F test. We are not gonna deal with this, but in the large sample, if you're having a mean, if you're having sample and we are having data related to mean, तो उसमें भी दो category होगी. Either we will be dealing with the single sample or we will be dealing with the two sample. डेटा अगर दो तरीके का डेटा हो सकता है, लार्ज सैंपल में भी दो तरीके का डेटा हो सकता है, जहां पे आपको एक ही सैंपल दिया हुआ है, या in other case we will be having two different samples. If we are dealing with a single sample and we are having a data related to its mean, then the Z test for the single mean will be applicable. And large sample, we are having data related to mean and we are having two different samples, then the difference of mean Z test may, the difference of mean of Z test will be applicable. Similarly, for the proportion, for the large sample, if we are having a single sample with the proportion is one of our statistic, one of our parameter. If we are having a single sample data and that data is related to the proportion, then single proportion Z test will be applicable. Instead of having one sample, if we are having two sample with us, then the difference of proportion Z test will be applicable. So for all this, let me pick my pen from the, wait, let me pick my pen. Why मैं इसके ऊपर क्यों इतना ज्यादा फोकस कर रहा हूं, देखिए, I'm gonna deliver 5 different tests. All that tests are Z test, and for each of this test, test statistic will be different. Test statistics, जिसको हम Z बोल रहे हैं, that will be different. All of this will have the different formulas related to Z. And why we need that Z? Because, as I said, that to accept or reject null hypothesis, we need to compare that Z with Z alpha. Z alpha, we are having that Z alpha from the previous table, but we need to calculate our Z's test statistic Z, and for each and every this particular test, that formula for the Z will be different. So you need to focus over there. If you're having a data related to single sample and mean, then the single mean Z test will be applicable. If you're having two different data, two different sample and data related to the mean, then difference of mean will be applicable. Similarly for the proportion as well as the standard deviation. Now for the standard deviation, there will be no confusion, because in that case of the standard deviation, surely we will have two samples. हमारे पास दो sample ही रहेंगे, and we'll be dealing with the difference of the standard deviations at test. Is it? So this is what we are supposed to go for. and this is the last part of our syllabus. So we are interested in this particular portion. Except this, एक और भी टेस्ट होगी, that is a chi-square test. Is it? We'll be not dealing with the small sample test. This is not included in our syllabus, but these all are included in our syllabus. This is what we are supposed to deal with. Okay, so are we good with this? Are we good with this data? If we are good, then we may continue. Are we good with this? Are we good with this particular data? समझ में आ रही है बात सभी को? Acknowledge on the chat box right now. Smriti is saying good. That's very good. D2D students are able to get this. Good, 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 good. So if you're good with this, then let me give you the process. कैसे करेंगे हम? देखिए, this is the process. Now, I'm not gonna read this because ये सारी बात हम कर चुके. We discussed this particular thing lots of time in the last two sessions, this and previous one. Just go through each and every step. एक बार आप read कीजिए चलिए. This is what the process for testing of hypothesis. In any of the tests, we will be following these steps only. यही 6 स्टेप होंगे जो हर बार हम फॉलो करेंगे, and we will decide whether we will accept null hypothesis or we gonna reject null hypothesis. So these are the 6 steps. I'm giving you 1 minute. Identify, and if अगर आप चाहे, then take a screenshot of this particular. इसका भी ले लीजिए. This is quite advisable. You need to take the screenshot of this quickly. Take a screenshot of this particular screen. Jaldi se. I'm giving you 3 minutes. 1, 2, 3 seconds. 1, 2, 3. Okay. And also take the screenshot of this. पहले तो एक बार देख लीजिए क्या है, फिर मैं बताता हूँ. आप स्क्रीनशॉट भी ले लीजिए, because this is the process which we are going to follow. अगर ये बात समझ में आ गई ना, अब तक की सारी बात समझ में आ गई, तो बात खत्म. इस चैप्टर का पूरा theoretical portion खत्म हो चुका. आप जो करेंगे हम examples करेंगे. That will be quite easy if you are good with all the previous data. Hopefully you have taken the screenshot of this. Now let me explain once again. First, what will we, after having example, what we will be doing? We will be set up a null and alternative hypothesis that will be labeled as H0 and H1, or we may use the different notation that is HA. After setting null and alternative hypothesis, we'll be checking the level of significance कि वो क्या दिया हुआ. That level of significance will be there in the example. If it is not provided, if the level of significance is not provided, then we will take level of significance as 5%. Okay. And as I said that in any of our question, we'll be dealing with these 3 figures only: 1%, 5%, and 10% only. If it is not specified, then we will take alpha as 5%. After setting the level of significance, we will decide which test to use. अब वो कैसे decide करना? How we can decide a test? Z test, T test, F test, or chi-square test. This is parametric test. This is non-parametric test. Suppose we are having some of the parameter over there, and our sample is large. Then वो कैसा है? क्या एक sample है, दो sample है? If we are having 2 sample and we are having a data related to the mean, then we will go for difference of means at test. If you're having a single sample with the mean, then we will go for mean Z test. Single sample mean Z test. Is it like that? If we are having 2 samples and having data related to that proportion, then we will move for the difference of proportion Z test. Is it? And each and every test will have that Z statistic. Then after deciding our test, we will go to identify the Z statistic Z. After having that particular, इसके लिए formula दूंगा मैं हर बार. I will provide the formula for each and every case. What will be the value of Z statistic? We'll calculate from that particular formula, and वो formula वही होगा common वाला. T minus estimated value of T divided by standard error related to that particular parameter T. Okay, that will be the general formula, but we'll be specifying, we'll be finding its actual form for each and every test. After calculating this Z, That's test statistic. We're going to compare that with the Z alpha. That Z alpha is a critical value. That we will take help from that particular table which I had already given to you. Or you may calculate your Z alpha. वो भी मैंने सिखाया है कैसे calculate करना है. And after comparing both that, if there will be only two cases, that Z will be less than Z alpha. In that case, we're gonna accept null hypothesis, or Z is gonna greater than Z alpha, then surely we're gonna reject our null hypothesis. उसको reject करेंगे. इस case में इसको accept करेंगे. Is it? If the compute value is greater than less than the table value, that means more Z is less than Z alpha, then we need to accept the null hypothesis. And in the other case, we need to reject the null hypothesis. So this is what the process we are supposed to follow throughout any of the tests, Okay? Are we good with this? Are we good with this? Are we good with this? Let me know quickly on the chat box how many of you are good with this. Hopefully all of you are good with this. समझ में आना चाहिए सभी को. Okay, Madhu ma'am is saying. Madhu ma'am is also good with that. Is it?
Yes, sir, I'm here.
Okay,
As
ma'am.
soon as you complete, I'll start.
Okay, ma'am. Okay. Okay, guys. So we will be dealing with the examples from the next lecture. Let me stop the recording over here.